Welcome to the Statistical Measures lecture. We said that statistics is the collection and analysis and displaying of numerical data. And we talked about collection of data, we talked about displaying data. Now it's time to talk about the third thing, and that is analysis of the data. We have many statistical measures out there, and there's two major types. One is called measures of central tendency. One is called measures of spread of data or dispersion. So there's two types of big statistical measures. The first one, measures of central tendency, it shows you how the data set you have is clustered around sort of middle value. In elementary school, you have learned about mean, median, mode, and we're going to just revisit these one more time. Mean is actually the average. That's a synonym for that. And it's the sum of the values in a data set divided by the number of values in the same data set. That is equal to the mean. So if you have a data set, let's say a whole bunch of numbers like this, you have 6, 10, 2, 4, 10, 8, 16. If you have a whole bunch of data values here and you want to find the average, you want to find the mean of this data set, this is what you do. You find the total or the sum of the values in the data set and you divide it by the number of values. So here, let's count 1, 2, 3, 4, 5, 6, 7. We have 7 data values here. So that means that the denominator is 7. So we're going to say mean or the average is 6 plus 10 plus 2 plus 4. We add all of them up. You can use a calculator. And we have to divide it by, here, number of values in a data set. So 1, 2, 3, 4, 5, 6, 7. So we have to divide this by 7. So we're going to add up the numerator. So this is going to be 10, 20, 30, 40, 56. Okay? So 56 over 7, and that is 8. So it means that the mean of this data set equals 8. That's how you calculate the mean or the average, okay? In maybe more advanced notation, we use X bar notation to show the mean. So if I'm writing X with a line on top of that, we read it as X bar. That represents the mean or the average. So I say X bar equals 8. And then each one of these data values are denoted by X with a different subscript. For example, the first data value would be X sub 1. Okay, that 1 is called a subscript or an index. It's written smaller in size at the bottom right corner of the letter. X sub 1 equals 6. The second data value is 10. So that will be X sub 2. Okay, X sub 3 is 2. And finally, X sub 7 is 16. Okay. And generally speaking, we show the data values with X sub I, okay, where I stands for the index. So here we're saying that the mean is the sum of all these data values. And to show any kind of sum or total in mathematics, we use a special symbol from Greek alphabet. It's called sigma. So this letter you see here, this symbol, is letter sigma from Greek alphabet, and in mathematics it means sum or total. So when I'm writing sigma x sub I, it means the sum of all these data values, the sum of x1, x2, x3, up to x7. That's the mathematical notation. After all, this is a senior course, and we have to learn about this stuff. The denominator is simply n, and n represents number of data. In this case, we have 7. So n equals 7 because we have 7 data values. Okay? If you have 10, n would be 10. So the numerator is the sum of the values in a data set. In a mathematical notation, sigma x sub I. The denominator is n, or the number of values in the data set. And I have written this same idea in expanded form. What the meaning of sigma x sub I is, it's x1 plus x2 plus x3 up to x sub n. That's the meaning of it, which means you're adding all the data values as I did before your eyes right here. So that's the story of mean or the average. The second one is median, which is the middle value basically in a sorted data set, or it's the halfway. So when I say sorted data phase, it's very important. So we have to sort the data before we even talk about anything. I don't think this data set is sorted, because we have 6, 10, and then we have a smaller value 2. And then we have 4, and we have 10, and then we have smaller value 8. So it's not like sorted from least to the greatest. I'm going to do that right now. So the smallest value is 2. So I go 2, and then we have 4, and then I have 6, 8, and I have 2 10s, and I have 16, I believe, right? So this is the same data, but it is sorted data set. Okay. So what do we do with this sorted data set? Well, we take the middle value. So we have 1, 2, 3, 4, 5, 6, 7 data values. So if you take 3 aside from the beginning, 3 aside from the back, the middle term, the middle number would be 8, right? So 8 is called the median. So the median of this data set equals 8. It's just a coincidence that in this case, the mean and the median happen to be the same number. Not always is the same case, okay? So median is the middle value. Now you may think, if instead of 7, which is an odd number, if instead of 7 data values, if we had like 6 data values, what would happen? Because in that case, 3 from the beginning, 3 from the end would be gone, and in the middle we'd be left with nothing. So let me show you something here. For example, if you have like 4, 5, and let's say 5, and then let's say 11, and then 19 and 20. If you have 6 data values like this here, so 3 from the beginning, 3 from the end, you will be left with nothing in the middle. So does that mean that there is no median? Obviously not. In these cases, when you have even number of data values, you take the average or the mean of the 2 middle values. So you're going to grab 5 and 11, just like that, and you're going to find their average. So what is 5 plus 11 divided by 2? It's going to be 8. So again, what a coincidence. Again, I got 8, but it doesn't mean that always we get 8. So if you have an odd number of data values, the middle value will be the median after you sort the data set. If you have an even number of data instead of odd number of data, in that case, you grab the 2 middle ones, in this case 5 and 11, after, of course, you sort the data, and you find the mean or the average of those numbers. So that will be 8. So that was the story of the middle value in a sorted data set, and that's the median. Mode, you may remember from before, is the value that occurs most often in a set of data. It's the most common data value, basically. So if you look at all these numbers we had before, there was only one number here, 10, which was repeated twice. So that means it's the most common data value in our data set. So we're going to announce that the mode, which is the most occurring data value, is equal to 10 in this example. Okay, the mode is 10, the median was 8, and the mean also was 8. It was a coincidence. Now, sometimes we have this data value repeated twice, which we call this bimodal data set. I'm sorry. It's like it's when you have 2 values. One is 10, one is another number that are repeated the same number of times. Then we call those bimodal data. Let me give you an example. Let's say if we have 2, 4, 6, 8, 10, 10, 16, okay. And let's say we have like 18 and 18 again, okay. So you see that 10 is repeated twice, 18 is also repeated twice. So this is what I wanted to say. We have 2 modes. In the previous example, we had 1 mode, and that was 10. But here we have 2 modes, because not only 10 is repeated twice, but also 18 is repeated twice. So these kind of data sets, I was going to say, are known as bimodal data sets. Okay, bimodal, it means that we have two modes instead of one mode. So sometimes you don't even have a mode. Imagine if I had 6, 10, 2, and 4, that's it. The first four numbers. If you had only the first four numbers, 6, 10, 2, and 4, you see that no data value is repeated. So you would say, sorry, we don't have any mode. The answer to the question would be no mode. But right now, we have one mode, and that is 10. And in this other example, we have two modes. One is 10, one is 18. You may even have three modes, or sometimes even more, in a bigger data set. Okay? So that's an additional note I wanted to mention about the mode. So measures of central tendency, mean, median, mode. These are three of statistical measures we have out there. There is four more. Obviously, in one lecture, I'm not going to say everything. So I have to take my time, one by one, explain all of these in detail. So measures of spread of data or dispersion are range, interquartile range, standard deviation, and variance. There's four of them. And we're going to talk about this in a totally separate lecture. It has some complicated calculations that we have to learn about them. But for now, this left side of the flow chart, which was discussion on measures of central tendency, we learned about that. Okay, there's three of them, and I showed you how to calculate them, and I may even give you more examples in future. Okay, so keep practicing, and we'll continue with another lecture later on. Thank you.